Hi guys, so in this video we will be solving this problem, shortest bridge. So first let's understand what the problem says. So we will be given a binary grid of zeros and ones. So here one represents island, group of island. Like here this is a group of island and this is a group of island. We can flip these zeros into ones and we have to tell what is the minimum number of flips required so that we can connect both of these islands. So what I meant by it is, what we can do is that we can flip these two zeros. One way is that we can flip these two zeros. So if I flip these two zeros, what I will get? I will get 1 1, and I can see that it is a group of island, right? So this is one option. One way is this. So what was the minimum? Minimum equal to 2 was the option for this. Now is there any other way? Yes, there are other ways also. What we can do is that instead of flipping these two zeros, I can flip this particular zero here also. Now also I'm able to connect these two islands, and this time I am using only one flips. So 1 is less than 2. So I have to tell the minimum number of flips in which I can connect these two islands. One more thing, if I am at a particular one location of at 1, what I can do? I can move in the 4 adjacent directions, means I can flip zeros in these 4 adjacent directions. Okay, so I guess the problem would have been clear till now. So now let's move on to the solution, okay, approach, like how we can solve this problem. Suppose if this is the group, if this is the question, so here there are two group of islands. This is one group of islands and this is the second group of island. So either I can try to move from group 1 to group 2 or group 2 to group 1. That is, I will try to find the minimum number of flips that are required from group 1 to group 2 or group 2 to group 1. Both will give the same answer only. So we'll start from any one. Okay, so let's suppose if we start from group 1, so there are 4 ones in this particular group. So, and if I am at a location of 1, I can move to 4 adjacent directions. So I don't know like which particular one will give me the minimum answer. Anyone, if I start from this location, it could give me the minimum answer, or this one, I don't know in advance. So what I will have to do, I will have to consider all the options in a particular group of island. Let's take an example what I just now said. If we start from this particular one, let's see what are the minimum number of flips required. So we can see that I will have to flip this particular 0 into 1 and this particular 0 into 1. Then I will be able to connect this group of islands, right? All ones are there in this group of island. This in this one I had flipped two zeros. Okay, now let's see one more example. If I start from this particular one, then I will have to flip only 1 0. Now also I am getting a group of island. If you see clearly, this is the group of islands. So here I was getting only one, so I don't know like which one will give me the minimum answer. So I will have to consider all the 4 options. So what I will do is that I will start from any one, like any one. If this position, I will apply DFS and I will find all the neighboring ones. That is, I will find all the locations of a island. Like if I start from 1, this is the group of island 1 1 1. So I will find 0 1 2, give me a second, 0 1 2, and let's check, index it 0 1 2 3 4 and 5. So what I am saying is that we will traverse this matrix, and whenever we will find a 1 represents is what? 1 means an island. So I will move in all the 4 radial directions, and I will try to, means I will apply DFS and find the locations of all the points which are connected by this island. So if I apply, I will get what? I will get 0 1 0 2 and 1 0 1 0 and 1 2, not 1 0, 1 1 and 1 2 are a part of island. So I get this. So all these are my valid options. Any one of these can give me the minimum answer. One more thing, if you look clearly, what we are doing is that if this is a group of island and this is a group of island, what we were doing, we were moving one step, okay, we were converting it into 1, then again moving one step, we were converting it into 1, we were moving it till we were not able to find a 1. after this point, what I'm seeing, if I'm moving to the next element, I'm seeing that it is a 1, it is a 1. Okay, so 1 represent what? 1 represent that it is an island, so I have reached the other island. So what if I consider these as edges, what we are seeing, that one by one we are moving radially in all the directions, one step at a time. That I can consider this edge. Okay, so I'm basically finding minimum, like minimum edge distance. So whenever we have to find minimum edge distance or something like this, what we use BFS, right? So the same we are going to use over here also. We are going to use BFS for solving this particular problem. Although like it is natural, you might have getting idea like we can apply BFS also, but we can see it in this way also. Like if you consider, like if this is an edge, means it is a block, it is another block, one by one we are moving radially, one step at a time, so we can consider it as an edge. So we have to find the minimum shortest edge. So for finding shortest edge, what we apply? BFS. So the same we are going to use. So what we will do, we'll maintain a queue. Okay, and initially let me redraw this matrix. Okay, so it is what? 0 uh 0 1 1 0 1 1 0 1 0, sorry, 0 1 1 0 1 0 0 0 0 1 1. Let's erase this one. Yeah, so what we will do is that 0 1 2 3 4, initially we will store all the points, starting points. Okay, and we will mark visited also. Like in applying BFS, we used to we mark visited so that we don't visit the same cell again. So we will mark them visited also. So let's store the all the cells. So let's suppose what is the index of this particular one, it is what? 0 comma 1. So we will store 0 comma 1. This particular is what? 0 comma 2. We will start, will whenever we will find a 1, we will apply DFS and we will find all the connected components, like whichever zeros or whichever ones are adjacently connected to each other in the 4 direction. We will collect the indexes of all those indexes and we will store it in a queue. So what we will get? We will get 1 1 and 1 2. Okay, so these are the collected, so these are a part of a island. Okay, and we'll mark them visited also. So let's mark them visited. This is visited, this is visited, this is visited, and this is visited. After this, what? Any 4 of these can give me the minimum, like minimum number of flips required to connect both of these islands, and each time I will move to the 4 directions 1 unit. So what I will do, one by one I will move and I will keep a counter. Okay, let's take a variable level. I will increase the level whenever I will get a 1. That means what? Let's suppose if I start from this point, what I will do, I will move to this point. I see it is a 0. That means I am in the middle area. Again I will move to the next point. Oh, I see what I saw. I reached 1. That means what? 1 means what? An island. So here originally it was 1, and in the second part it means there was island. So if I have reached a 1, that means what? I am able to connect the island. So I will return whatever is the will be the value of level at that particular time. Okay, so let's see this in action. How will it actually work? Okay, let me erase this. So initially all these 4 points are visited. After that, what we will do, we will one by one remove the elements. 0 comma 1 will be removed. Okay, 0 comma 1 will be removed. We will move to all the 4 possible directions up. If we move up, we will be out of the grid, so we will not move over there. If we move to left, okay, so we see we are visiting 0. So this is a 0, so we will add it back to the queue. Current our level value is what? Level value is 0. So all these 4 elements are at our current level. Okay, level value is 0. Now 0 comma 0 will be added into the queue. Let's add it with different color. Okay, now we will move in the down direction. From this particular point, if I move down, I am seeing that it is already visited, so no point to move. From this particular point, we have moved up, left, down, and if I move right, this is also already visited, so no point of visiting. Okay, now again remove the next element from the queue. What we will do, 0 comma 2. Now this is the point 0 comma 2. Let's move in the top direction. If you move it in top direction, what we are seeing is that what? It is out of the grid, so we will not move. If we move in left direction, then we will reach here. It is already visited, so no point to move. If you move in down direction, it is already visited, so we will not move. If you move in right direction, we are reaching to 0 comma 3, it is not visited, so we will mark it as visited, and it is 0, that means we are in the empty area, so we will simply add it back to the queue. So 0 comma 3 will be added into the queue. Okay, now remove the next element. Next element is what? 1 comma 1. Next element is 1 comma 1. So 1 comma 1 is over here. If I move in top direction, it is already visited, so no point in visiting back again. Move in left direction, I am visiting to what? 1 comma 0, it is not visited, mark it as visited, and 0 represents it is the area in the middle of, means it is area somewhere between two islands, so we'll add it back to the queue. So 1 comma 0 will be added into the queue. 1 comma 0. Okay, now next we'll move in downward direction. From this point we'll reach to what? 2 comma 1. So 2 comma 1 is not visited, mark it as visited, it means it is 0 and it is somewhere between these two islands, so add to the queue 2 comma 0. Next element, next is what? We'll move to the right of this point, but right is already visited, so no point in visiting back again, so it is also done. So let's erase this part. Now remove the next element from the queue. Let's shift the queue little over here. Okay, now remove the next element. Next element is what? 1 comma 2. So next element is 1 comma 2. If you move in up direction, it is already visited, so we will not move. If you move in left direction, we are seeing it is already visited, so no point in moving over there. If you move in down direction, so we are reaching to 2 comma 2. So 2 comma 2 is not visited, mark it as visited, it is 0, that means it is somewhere between both the islands, so we will add it back to the queue. So 2 comma, what is this point? 2 comma 2. 2 comma 2 will be added into the queue. Okay, now let's move in the right direction. So right direction will be what? Right direction is 1 comma 3. 1 comma 3 is the right direction, so 1 comma 3 is already not, also not visited, so let's mark it as visited and add it into the queue. So 1 comma 3 will be added. Okay, now we have exhausted the first 4 elements. That what does it means? That at each of these 4 locations 1 comma 1, I have tried to move in all the 4 directions in 1 unit. Like I have tried these all directions 1 unit, and I am not able to, not these ones, yeah, in all these 4 directions 1 unit, so I am not able to get what? Any single one in 1 unit radius, means in 1 unit I am not able to get that. That means what? Sorry, in 0, like in simple flip, I am not able to get this particular anyone. That means what? I have not reached the another island till yet. So what I will do, I will increase my level by 1. Okay, now I will remove one by one, move 1 unit from these points. I will check whether I am reaching the level or not, I am reaching the another island or not. If I get a 1 anywhere, that means what? I have reached the other island. So this is the flips which I am required. But if I am not able to reach 1, that means what? I am still in the middle of both these two islands where there are zeros, so I need to flip more zeros. Okay, so let's continue with our algorithm. So our level value is 1 incremented. We have exhausted the first 4 elements, so we incremented our level by 1. So now let's remove the next element. Next element is what? 0 comma 0. 0 comma 0. So I can go in the top direction from 0 comma 0. Like if I am over here, I can move in the, sorry, 0 comma 0 is over here, sorry, 0 comma 0. I can move in the top direction, so this is out of the grid, so I will not go over there. I can move in the left direction, this is also out of grid, I will not go over there. Okay, I can go in the downward direction, but it is already visited, so we will not go over there. And yeah, only these 4 options. Yeah, and I can go in the right direction also, but right direction is also already visited, so we will not go over there also. So no possibilities for 0 1, so it will be simply removed. Okay, now since we have done with these elements, let's erase these elements for now, and let's shift the queue left direction in the leftwards, so that we will be able to add more elements. Okay, yeah, let's remove the next element. Next, 0 comma 3. So 0 comma 3 is the next element. 0 comma 3. Okay, so I am at this particular location. I can move in the upward direction, but I will be out of the grid, so I will not take this one. I can move in the left direction, but it is already visited, so I will not move over here. and I can move in the downward direction, but it is also already visited, so I will not take this step. Then I can move in the right direction, so I will reach to what, 0 comma 4. 0 comma 4 is not visited. Okay, we'll mark it as visited, but what we are seeing is what, 0 comma 4 is what, 1, and 1 represents what, an island. And I have started with this group of island, that is from left group of island. Okay, and what I am doing is that one by one I am moving one step, and I am converting 0 into 1, converting 0 into 1. But this time, what is happening? When I reach to this point, this is what? This is already 1. That means what? I am able to connect these two islands. Since in the middle, whichever 0 was present, I had already converted into the 1. And this is, and I have reached a 1. That means what? I have connected these two islands. So I need to stop. I'm no longer required to calculate more. Whatever the current value of level, it is the minimum value. Why? Because we are using BFS technique, and BFS gives the minimum length. So whatever current level is there, we will simply break our iteration and simply print whatever is the current value of level. So, and so according to our algorithm, what we are getting is 1. And if we check also, or in our dry run also, what we have saw, that 1 is the answer for this case. Let's see that also. This is the matrix: 0 1 1 0 1 1 0 0 0 0 0 0 1 0 1 1 1 1. According to our algorithm, only one flip is required. And if we see, if we simply flip this 0 into 1, like this 0 into 1, what we are getting? We are getting this group of islands, like we are able to connect it by simply one flip. So this BFS technique is working fine. Okay, so what all we are going to do, like let me recapitulate it again. What we will do is that in our algorithm, whatever we'll do, we'll traverse this traverse matrix. Whenever we will get a 1, what we will do, we'll apply DFS, and we'll find all the connected components, like all the ones which are connected to each other adjacently, DFS, and we will store it in a queue, like store the locations on a queue. After that, what we will apply BFS to all these elements, and we will move 1 unit radially in all the forward, in all the 4 directions, till we encounter a 1. When we encounter a 1, what does it represent? That we reach the other island. So we'll simply return our whatever is the value of our level, that will be our answer. Okay, and once all this DFS, suppose if there is a case, let's suppose there is a case something like this 1. Okay, there is a case 1 over here. Yeah, only there is only one island. Suppose there is only one island, no more island. So will we be ever be able to reach other island? What will happen? We'll one by one travel from here. We'll convert it. We'll not convert, like we'll travel one direction, then we'll move over here, but we'll never be able to reach any other one. So in this particular case, if after all this iteration, when this BFS ends, we will simply return what, -1. That means what, there is only, means no possible answer if there is such case. Okay, so after the whole this algorithm runs, our queue gets empty, and if we are not able to find any value for level, that means we will return -1. Okay, so I guess this algorithm would have been clear to you. So now let's try to code it, and let's see whether it is working or not. Okay, so now let's try to code this problem. So first let's import the header files. So we have, let's first take the input. This snippet will be provided to you. You have to write only the main function, but for now I'm taking the input. So cout, name of the function will be shortest bridge, paste. average of vector 1, simply return 0. So from here our part starts. Okay, so we'll write a function integer shortest bridge vector of uh, vector of vector of integer. Okay, so now let's see what all we are required to do. So as we discussed, first we will traverse the matrix. Okay, so first let's traverse the matrix for integer I equal to 0, I is less than vector 1 dot size. Okay, then for integer j equal to 0, j is less than vector 1 of 0 dot size plus z. We will check if vector 1 of I comma j is equals to 1, then what we will do, we will call a DFS function. Okay, so for D we will store it in a queue. So let's make a queue of pair queue. Okay, so although C++ has an inbuilt pair class, but we are going to use our own class for now. So let's write a class. So let's make a class pair. Here it will be semicolon, integer row, integer column. Let's make all of this as public. Okay, let's write the constructor integer row, integer column. Inside this row equals to row and this column equals to column. So we have made the pair class. Why we are making pair class? Since as I have explained you, we are storing I comma j, so we need an object for it. So we are going to use a pair class for it. So we have made a pair class. Let's make one more variable boolean flag equal to false. Let's initialize it with false as BFS. So we will be requiring a visited array also. So let's make a visited array vector of boolean visited. Oh, let me full screen it. I forgot to full screen it. Now let's write the code. So where were we? So vector of bool visited of vector 1 dot size and vector of bool of vector 1 of 0 dot size. Okay, so now we have all the things. Now let's call the DFS function. We'll pass the queue and let's see what else we require to pass in the DFS function. So let's make a function void DFS. We'll pass a queue of pair to it. Okay, along with that we require, what else do we require? We require source row, that is the current row in which we are currently present, source column. Okay, along with that we require the visited array, vector of bool reference visited. We also require the original array. So let's pass vector of integer vector 1. Let's pass it in our parameters also. So source row will be I, source column will be j, visited array will be visited, and our original vector, that is v1. Okay, after this what will first, let's complete the function of DFS. So what we do in DFS, we first mark as visited. After that let's add the, so q dot add pair of source row comma source column. Now as if we are at an index, so we were allowed to move in the 4 directions. So let's move in the 4 directions. So for that we will require, like if we are over here, where can we move? We can move to -1 comma 0. If we move in the rightward direction, it will be a 0 comma plus 1. Here it will be 1 comma 0, and here it will be a 0 comma -1. So our direction array will be what? -1 0 1 0, and dy will, direction array in y direction will be 0 1 0 -1. So let's make direction arrays as well. So let's make two array, a vector of integer direction array dx is equal to what? -1 0 1 0, -1 0 1 0, and vector of integer dy direction in y will be what? 0 1 0 minus 1 0 1 0 minus 1. Okay, so after that we'll move in the four directions. I is less than 4 plus I. What will be our row will be what? Our source row plus of direction in x plus our column will be what? Source column plus of direction in y. Okay, so now we will check that whether this row where we want to go, whether it is valid or not. So if row is less than 0 or column is less than 0 or row is greater than or equal to vector 1 dot size or column is greater than or equal to vector 1 of 0 dot size, then where we want to go is out of the board, so we will not visit these parts. Okay, one more thing, if where we want to go, that is this vector 1 of row comma 0, if it is 0 then it is not a part of the island, so we'll skip this also. Otherwise we will check if where we want to go, if it is not visited, then we will make a DFS call to this part. So Q, our source row this time will be what? Row, source column will be column, visited array will be visited, and vector 1 will be v1. Okay, after this DFS will be done. Now let's come back here. So once we have find a 1, we have collected all the neighboring ones, that we have collected all the indexes of the island. After that we can break this loop. Okay, so we will check if flag, then simply break the loop. Okay, so till now what we have done, we have traversed the matrix, we have applied DFS and collected the indexes of this particular what island. After that what we have to apply, we have to apply BFS. So let's apply BFS. For that what we will do, let's add some spaces. For applying BFS, let's make a variable level that we are going to use. So let's make level equal to 0 while q dot size is greater than 0. What we will do, let's make a variable size equal to q dot size. So we were calculating like one by one, removing the element and checking it. So while size minus minus, let's one by one remove the element, where removed element is equal to what? Q dot front. After that we'll remove it. Okay, now what will be our row? Our row, this part is exactly same as this part, so we can copy it from here also. Let's copy it, Control C, let's paste it over here, Control V. So here it will be not HR, it will be removed element dot row, and here it will be what? Equals to removed element dot column. So one by one we are checking the four directions in which we can visit from a particular spot, and the four directions, if these four directions are out of the bound, then we will skip it, we will not visit them. Otherwise what we will do, we will check if it is already visited, then also we can skip it. If visited of row comma, then means we will skip it. Otherwise what we will check, if where we want to visit, if it contains 1, that means we have connected the islands. So if vector 1 of row comma column is 1, then we will simply return the level. Otherwise what we will do, we will add it into the queue. So q dot push pair of row comma column, and each time we will increase the value of our level. Okay, and finally if the queue is empty, we have completed our DFS and we have not found any answer, that means what? We have to return -1. Now let's see whether we have done everything correctly or not. We have traversed the matrix, it was over here, we traversed the matrix. Okay, whenever we find out 1, we have called DFS to get the connected components of 1. After that we have breaked it, then we have applied the BFS. So one by one we are removing the element and checking if it is equals to 1, then we will return level, and if it is out of bounds, then we are simply returning it. If it is already visited, then simply skipping it. One more thing, visited of row comma column equals to true. Yeah, and finally we are returning the level, and if the VFS is completed and we are out of the loop, then we are simply returning -1. Okay, now let's try to run this code and let's see whether it is working or not, or are there any errors, something like that. Let's see. So there are some errors, so let's check them. At line number 20 there is an error, so it is it will be q dot push. Okay, let's check them. 20, then at 58 remove dot row dx of I. Okay, at line number 58, so let's see what is the r equal to remove dot row plus of dx of I plus of column of I. So dx, we have defined dx over here, so what is that? Okay, line number 58, where is that? Let's try to run it again and let's see if it resolves or still there is there. Okay, bridge integer r, removed element dot row plus of dx of I was not declared in the scope. Okay, let's see it. We have made row and column over here. It's correct. It is correct. Integer r equal to remove dot row, column equal to remove dot column. So so yeah guys, here it was the mistake, like we copied the code from over here and we did not copy the for loop part. So for loop is not written over here, so that's why it was the error. Plus I. Okay, let's write this part inside the for loop. Okay, so we have written it inside the for loop. I think now there should not be any error. Now let's check once again that whether everything is correct or not. So we have checked DFS, bridge part is okay. State vector run of row. See, one more thing, like we have not taken the input over here. I is less than n plus I for integer j equals to 0, j is less than n plus j scene vector 1 of, let me full screen it. Yeah, so scene vector 1 of I comma j. Okay, now let's try to run this code. Let's see, are there any errors? Well, it is correct, so we are getting correct answer. Let's try to submit it. Let's see whether it is, yeah, it is getting passed. So I hope you guys would have understood the solution.